Okay, now, this is all from before, just to put things in context. But now we're going to find a polynomial with given zeros of given multiplicities. So let's see what that means. For example, find a polynomial with zeros at -5, 1, and 3 with multiplicities 2 for the 0 at -5, 2 for the 0 at 3, 1 for the 0 at x equals 1. Okay, well, it's actually quite simple. We have zeros at these points. We're going to have x plus 5, x minus 1, and x minus 3 as factors. But what we mean about the multiplicities is the x plus 5 is going to appear twice. It's going to appear with multiplicity 2. So that would mean we'd have an extra x minus 5 in here, x plus 5, sorry. And multiplicity 2 at 3, well, that means we're going to have another x minus 3. So this is actually a ln. That's okay. And that equals then x plus 5 squared. And we're going to do the x minus 3 squared next, because we usually list multiplicities in decreasing order of multiplicities. List the factors in decreasing order of multiplicity. So we have this function. Okay, well, we can easily construct an approximate graph. If we multiply all these out, the leading term is going to be 5. And, in an exercise, I'll probably ask you to multiply some of these out. Okay, but we have x equals -5. So here's -5, and the multiplicity is going to be 2. At x equals 3, we're going to have a 0 of multiplicity 2. And at x equals 1, we're going to have just a regular old 0. And multiplicity is 2, the 0 is at 3. Okay? Because the leading term is x to the 5th, this is going to behave like an x to the 5th power function away from the zeros, which means it's going to start out low, it's going to come up, it's going to level off, and then it's going to go on up. And as it levels off, that's where the wiggles are going to occur, that's where the zeros are going to occur. So we come up from the depths toward x equals 5. The multiplicity is 2, which means that in the neighborhood of x equals -5, this behaves like the x plus 5 squared the transformed basic function, the transformed x squared function, x plus 5 squared, multiplied by whatever the value of these terms is near -5. So it's a vertically stretched x plus 5 squared function, which means it's going to be a parabola. Now, since we're coming up from below, the stretch factor, vertical stretch factor, is going to be negative. It's going to come up here, and then it's going to go back down. Now, it's probably going to go back down a lot further than I can go, but I won't go that low here. We'll just come down here, and we'll come up through the 0 at 1. Okay, because in the neighborhood of x equals 1, this is just like the x minus 1 function, which is a linear function close to this point. And then we have to turn around and come back to 3. And, of course, then we've got to go off in the positive direction. Okay? So it's a good thing that we have a multiplicity 2 at 3, or we wouldn't be able to turn around, would we? So we come here, we have a multiplicity 2, another local parabola. It's like a parabola very close to 3. And then it goes on, and it's no longer going to act parabolic, it's going to act like the cubic function. Okay? So there is this polynomial. So if we wanted to find a polynomial with zeros and multiplicities, And the multiplicities would be these multiplicities. Well, then we'd have this function with a square here and a square here. If we want the y-intercept to be at 0, 15, of course y-intercept here is negative, it's going to be a lot bigger than 15, but we can always multiply by a negative, okay? If we can do a negative vertical stretch, flip things around the axis. So if we still have this, now I didn't work through how we get this, because I didn't, well, yeah, okay. What's the y-intercept of this function? Okay, well, x is 0, we have 5 squared, which is 25, negative 3 squared, which is 9, 25 times 9 is 225, and times negative 1, which gives us negative 225. So here is .0, negative 225. There's the y-intercept. So how do we reason this out? We vertically stretch the polynomial by factor. Negative 225 over 15. Okay? Now 15 goes into 225. Wait a minute, something's wrong. Goes into 30 twice, then 14. Yeah, that's right, 15. So 225 is the square of 15. And that's just a coincidence. I didn't plan it that way, but this would be negative 15. Oh, and that's totally wrong. Put the wrong numbers in there, and I need to be more careful. And you need to be more careful. So it should be 15 over negative 225, which is negative 1/15. So if we take 1/15 of 225, we get 15, and negative 1/15 of negative 225 would be plus 15. So the intercept is going to be 15 times closer to the x-axis, and it's going to be positive. Multiplying everything by negative 1/15 is going to make this thing going to end up with something much like this. Come here, turn around, and then go back down. Okay. Now every point of this green graph would have to be 15 times closer to the x-axis than the corresponding point on the original white graph, and on the other side of the axis. That's what happens with a vertical stretch factor of negative 1/15. So that the polynomial would be negative 1/15, and it wouldn't simplify. Still negative 1/15 of this. Of course, this would be squared, and this would be squared, this would be squared, this would be squared. So all we're saying is that if this ends up squared and this ends up squared, that changes your y-intercept. It changes what we do with the vertical stretch factor. You've got to go from a y-intercept of negative 225 So y-intercept of plus 15, which means we've got to multiply every y-coordinate by negative 1/15, which is what happens when we do the vertical stretch. Okay? And then, you know, we could do something similar over here. We'd have to square this term. If we wanted the intercept to be negative 225, this number would end up different. It would end up 15 times as great. This would be 1/15 times as great, and you can work it out. So I'm not going to write that down. I'll probably ask you to work it out for homework. Okay, so find a polynomial with a given number, with given zeros, a given multiplicity. That's very simple. You just put the multiplicity in each zero, and then you proceed as before. Same steps, same ideas.